And let me start sharing my screen. And let me click on this. I see. Hopefully that helps. Okay, so we'll start here. If I can come on, there you go. All right, scholars. So welcome. Here we're closing out. I think this is like week 13. Just kind of a quick like synopsis or overview of what to anticipate in upcoming weeks. So today I intend to get through as much of the homework of section 9.5. We kind of have like an extra week in there the way everything is kind of set up. So I think that next week I can do one or two things. Either start reviewing like old material, like we can go through like exam 1 and try to, recall as many concepts as we can, or we can like do the second half of this section. But we'll I guess reviewing the exam sounds more alluring. Well, let me see. So we have this week, and then we have all of next week where we meet like normal. The week after next, we'll meet on that Monday, and then more than likely we will not meet on that Wednesday right before Thanksgiving. So then we'll part ways for the Thanksgiving holiday, all right? And then the week after Thanksgiving, that's like the last week of class. So we'll meet on that Monday and that Wednesday. That Wednesday, November 30th, is the last day of class. Not that we meet on Thursdays and Fridays, but that should be the reading period. So you really shouldn't be meeting for any of your courses on that Thursday and Friday, which is like December 1st and 2nd. So then the following week after the last day of class is the week of finals, right? It'll be here and over with in the blink of an eye. I want to say that I scheduled my finals or my exams to become available just like the other exams on the Sunday. So that's like Sunday, I think it's maybe the 4th or something like that, whatever that Sunday is before the first full week of December at 11 a.m., the final exam should become available. And so what that means, there's a couple of things there. So one, that means we're rapidly approaching the hard deadline, at the end of the semester, the Friday, December 9th at 11:59 p.m. That's the hard deadline when everything is going to lock out. Like we can't do anything past that because I have to calculate grades. So what that means is now is a good time is to go ahead and be done with Pearson. So get it all done and get your grades to wherever you want them to be. You can go back and improve any score as long as if it's below 90, then you can improve the score. And if you are trying to improve your overall grade, the order of priority, you definitely want to prioritize old exams first as they count for 80% of your overall grade. And then the last thing you want to prioritize is the homework, because that's going to be a lot of work for a little bit of points. So I don't want you trying to put too much energy and focus and attention on the homework. The main thing is like get your exam scores wherever it is that you'd like them to be.
I have something to ask about like the test that we last did. I did it and I got a 90. There was one question that I put in the question, and I put in the answer for the question, and the question was right, but it said it was formatted wrong, even though I don't even think I think I formatted it properly. So I don't know.
Just remind me closer towards the end of class. Like I usually stop at like around the 40-minute mark. Just bring it up again and I can take a look at it.
All right.
And we might be able to get you some credit there.
All right. Thank you.
Mm-hmm. Just remind me. That's what I was talking about. You got to remind me though, because I will forget.
Like 140, I can remind you?
Yeah. Just at the 40-minute mark, 35 minutes. I'm trying to see if there was anything else. The main thing, just go ahead and try to get the things on Pearson in order as best you can. And as soon as possible. It's just a good idea to just go ahead and finish that stuff out. So that way, once Pearson is in order and you've gotten it to where you want it to be, there's only two things that you're going to be responsible for at that point. One, you just got to be sure to keep getting your daily attendance credit. You don't want attendance credit to like get in the way and muck stuff up. And then secondly, you're really just gonna be waiting on the final exam, right? And with the final, it's the usual rules, unlimited attempts. The system is set to take your highest score, but there's not gonna be a late penalty associated with the final, because once the final is due, everything is due, right? So you can't do the late final.
How much is attendance for credit?
So it doesn't really factor into your grade.
Oh,
It
okay.
what it does though, it's basically record keeping.
Oh, okay.
And like you just don't want to be in a boat where you have too many unexcused absences, because some students did get administratively withdrawn. And for me, I don't really want attendance to be an issue. So they have to go through these hoops like to get added back to the class, but that can mess up your money. Like you don't want to be dropped and then trying to add back, and that's a headache. You don't want to have to go.
I understand.
Yeah, the simple thing is just show up and keep it moving. Yeah, I can't think of anything else. So you guys have the right idea. If you have questions, just feel free to unmute yourself. And so we'll take some time today. I'm just noticing the date. Wow, that's interesting. Give me just a moment. Get my screenshot. Should have some new ones. Yeah. Sorry, I do this thing with like digital clocks. When you have repeating numbers, we call that the angel numbers, and so I'll screenshot it and like send it to a couple of friends. Anyway, that has nothing to do with anything. So let's take a moment and let's go through as many of the questions from section 9.5 binomial theorem as we can. Let me think. What for the student that had the question about the exam, what's your last name? Let me see if I can go ahead and do this thing now. So there. All right. Or maybe not. Let me check Zoom. Oh, yeah, we got a few people. Oh. Just letting in latecomers. I checked it a little bit earlier today, but that's okay. So the student that had the question about the exam, are you still there? You can.
Yeah, I'm here.
What's your last name?
Omakanya, leader Omakanya.
Okay, give me just a moment.
It was a question with decimals. I forget. Let me look at it too.
Was it on the last one that you submitted?
It was on, I think it was the second to last one. Let me check real quick.
Was it? Okay.
Exam 3. Can I look at my old test results? I don't even think I can look at it now.
You should be able to. Let me pull it up on my end. Give me just a moment.
Yeah, I don't think I can look at it now. That's weird.
So if I go here, I'm gonna actually.
I think I have a screenshot.
Yeah, you can forward it to my email, but I can pull it up.
I think I already did.
Grade book. Let me see. Manage my student. Right here. You said, okay. Was it the one that you scored a 90 on?
Yeah.
All right, let's review. Do you know which question number it was?
I think it was it's either the last two questions, I think.
So it's either 20 or 18.
Yeah, 18. It's 18.
Fraction 18, okay. Graphing calculator to find the following. Use a graphing calculator to find the following. So type an integer or decimal runs to 3 decimal places as needed. Oh, decimal. You put a fraction.
I put a decimal. I put 63.5 instead of a fraction. It says type an integer or decimal, round it to 3 decimal places as needed.
My records show that you put 127 over 2 instead of 63.5. Let me see.
Yeah, I put 63.5.
No, it says you put 127 over 2.
I have a screenshot. 127 over 2? Okay.
Just give me a second.
Instead of what? What was the actual answer?
You put a fraction instead of a decimal. But I think it's.
Oh, okay. I understand now.
Yeah. Yeah, that was, you just, let me see. I'll go ahead and give you credit for it because it's correct. It's just the wrong formatting, but that's fine.
Yeah, I should have. I thought I thought it was either a fraction or a decimal. That's what I thought. So
It's,
yeah.
I think I went on and gave you credit for that one because it's correct. It was just the wrong format. So,
Thank you.
yeah, you should see the change. I think I hit submit grade. So we're going to go with that. I'm going to close it.
All right, thank you.
Yep, it's there. Okay, let's close this out. Let's see, we left off here, and let me share my screen again. Let me check one more time, you guys. Looking good. Go ahead and mute you guys. Yeah, okay. Come on. Share the screen. Start the broadcast. Okay. All right. I think we're good there. Okay. Man, if I say okay one more time, complete the following statement. The expansion of this has how many terms? So I think we said it was n plus one, right? Like for instance, if you think of like a binomial squared, you finish with a trinomial. You finish with 3 terms. That's kind of how I get it. So it's like n plus 1 terms. All right. On to the next one. Determine whether the statement is true or false. Okay. So I think I would like to do a poll. So what I'm going to do, can I do slide over? And I want this guy back. That looks good. Let's go here. Start the poll. Multiple choice. Yeah, I think that's good. And yeah, this size is pretty good too. Okay, so wait a minute, it doesn't look right. Launch. Yeah. Okay. So there's a poll that's live for this question. We're asked to determine whether the statement is true or false. Every coefficient in the expansion of x plus y quantity to the power of n for n strictly greater than 1 appears exactly twice. Every coefficient exactly twice. What do y'all think? What do you think? Let's see. So it says the statement is false because the expansion of this, every coefficient appears only once for all n and r. The statement is false because when n is even, the coefficient of the middle term appears exactly once, right? The statement is true because the terms in the expansions are symmetric. The statement is true because the terms in the expansion are symmetric. Therefore, every coefficient appears twice. Okay, there is at least one vote for D. I think I'm going to go against the popular opinion. I personally am leaning towards B. Yeah, I'm going to go with B. Right? Because like I'm thinking about like Pascal's triangle. Right? I think so the coefficients when we were expanding the binomials came out of like Pascal's triangle, where like row 0 starts with the 1, row 1 was a 1 and 1. And then if you think about the triangle, it like went 1, 2, 1, 1, 3, 3, 1, and then like 1, 4, 6, 4, 1, right? So it's like, I think the odd ones were symmetric, or some of them were symmetric and some had an extra term in the middle. All right. So anyway, that was an interesting question. Okay, so let's end this poll. Go to the side. Come on. There we go. So we're asked to evaluate. We have 15 factorial over 12 factorial, right? Okay, so we can kind of do this one in the following way. Let's start off with like a fraction. Now on top, 15 factorial just means 15 times 14 times 13 times 12 factorial, right? And then on bottom, we still have 12 factorial, right? So I noticed at the top, I didn't go all the way, even though it does mean go all the way to 1, I just didn't write it that way. So I wrote it until I got a factor on top that matched the factor on the bottom. So I said 15 times 14 times 13, and then the rest is just 12 factorial. So now it should be clear that the 12 factorial on top cancels the 1 on bottom. All right, so that's gone. I can get over there. And the 12. And so then we're left with 15 times 14 times 13. Hey, Siri, what's 15 times 14 times 13?
15 times 14 times 13 is 2,730.
2,730. All right, we're gonna go with that. Hopefully that made sense, all right? So again, if anything is not clear, feel free to unmute yourself. Evaluate this combination, right? So this is a combination. This means 7 objects taken 6 at a time, or you can use that long formula. Again, this, you know, the way I like to do it, like basically, I'm really on top, I'm really doing 7 factorial, but I'm only going out 6 spaces. And then on bottom, so we can actually do this one similar to how we did the previous one, right? Because it should be like 7 factorial on top, but let me think about it. Yeah, that's fine. Okay, let me just, because I'm avoiding trying to write something. I'm just gonna put the answer. The answer is 7. Like I'm just being lazy. I'd rather do a different one that didn't have so much extra unnecessary work, so you can see it. If you need to see the details on this one, I can write it out or explain it. I'm just putting that for now because it's just a lot of extra stuff that was unnecessary. This is another one that's similar, right? Like when if it's n choose 0 or n choose n, those are always 1. If it's n choose n minus 1 or n choose 1, then those are just going to be n, right? So like this one is an example where it's n choose 1, so that one should just be 12. I'm looking for a more interesting example to explain why those are the way they are. This is a better one, right? So the technique that you see me do here, you can actually do it on the previous examples and they'll make more sense. So the way I like to do it, now you could follow the formula. If you need me to do it the formula way, just let me know and we can walk through the formula. But the way I like to do these, on top what I'm going to do is 7 factorial, but I'm only going out 2 spaces, right? So on the top, I'm going to just do 7 times 6, all right? It's really 7 factorial, but I'm only going out 2 spaces. On bottom, I'm doing 2 factorial. So that's 2 times 1. So then if I cancel, 6 divided by 2 is 3. 7 times 3 ultimately is just 21. Okay, let's see if we can do another one. So we're asked to expand this using Pascal's triangle. So this comes from row 4. Okay, I guess I was thinking that it's like maybe I can do this without writing, but I think we need to take some notes on this one. Let me just check on you guys over here. The chat looks good, and I think we're good there. So let me suppress this. Okay, let's take a screenshot, and we're going to take some notes. Yeah, that looks good. So we're just going to take it from like here. This is all that we need. Now, I guess we'll go ahead and follow the instructions. The access to use Pascal's triangle. So that's the way that we'll do it. I think I am partial to the binomial theorem. I think I do prefer that route, but you know, with the access to use Pascal's triangle, so we're just gonna go ahead and do that. If I can get this to behave. Oh my goodness, undo. Come on. Maybe that'll work, okay. There we go. Boy, that was like difficult for no reason. Okay. So Pascal's triangle, let's start off with that. So that one is like so we're using row 4, so let's get to row 4. So for instance, if we start with row 0 is just a 1, and then row 1 is just 1 and 1, and then row 2, so it starts with the 1, and then 1 plus 1 is 2, and then it finishes with the 1. Then row 3 starts with the 1, 1 plus 2 is 3, 2 plus 1 is 3, and finish with 1. Thank you. We are halfway. Like, I'm not gonna lie, I do like these 50-minute courses. Like, I feel like when I just starting to get into my rhythm, we're almost done. I'm like, it's like bittersweet. But I've taught courses that were like 3 and 4. What the hell? I've taught courses that are like 3 hours and 4 hours at a time. I'm like, oh my God, we kept taking breaks at every 50 minutes, but whew, those were intense. I was like, man, I'm struggling. And that's essentially what I'm doing with you all, but it's at least broken up so the energy kind of shifts or whatever. So because it's to the power of 4, we're going to use row 4. 1, 4, 6, 4, 1. So these are the coefficients, and we're doing x plus 10 to the power of 4. Okay. So let's do this. Anybody got a favorite color? I think I'm going to use what you guys said last time. Blue, did I hear blue?
Yeah, blue.
And then, so 10, right? To the power of 4. Okay, so let's see. So if we're going to expand this, right, we're taking row 4. So then the 1 just comes down from Pascal's triangle. Now the x's are going to count down. So we're going to have x to the power of 4. And the blues are going to count up. So 10 to the power of 0. Then we say plus. Now we take the next part from Pascal's triangle, which is 4. X's are counting down. So now that's power of 3. The 10s are counting up. So now it's power of 1. And you just continue that pattern until you get to the end. So next is 6. X's are counting down. 10s are counting up. Okay. Then the next one is what, 4? 4, 3, 2. So this one is now a 1. 0, 1, 2. So this one's now 3. So, oh no. I'm assuming that you guys are on campus. Just curious if like y'all, not that you got to answer, but I would encourage you to like get out and explore the city, which obviously, I would imagine that you would do. But like I really enjoy like the Atlanta Beltline. Like that's one of my favorite features of the city because the vibes there are just usually good. Like people are exercising. Just usually it's good vibes. And like yesterday it was like summer. I was like, what is going on here? I was just like, well, thank you. And I just keep it moving. And the last one is power 4, right? So then once you do that, then you just go and simplify each term. So for instance, this guy goes to 1. That one's already a 1. So then we have x to the power 4. The next one is 40. So we're going to say plus 40 x cubed. Okay. And then the next one, 600 x squared. Okay. That looks good. 4,000 x. And then 10,000. This one goes to 1. Plus 2, 3, 4. Okay. Hopefully we didn't get booted because sometimes if you're way too long, it'll crash. All right, let's see if we can submit this. And then I thought that they had passed a law or a bill or something that they weren't going to change the time, and they still keep changing the time. And I'm like, come on, will y'all please? Why do you keep doing that? Let's see. Come on. Okay, let's just try to work with this. So we got x to the power of 4 plus 40 x to the power of 3 plus 600 x to the power of 2. Oh, wait, back up. Gotta get out of the power. So then plus 600 x squared plus 4,000 x plus 1, 2, 3. Okay, I think we got it. Okay, that looks good. All right, let's go with it. Okay. Let's do another one. Pascal's triangle. So we already have the triangle available. Okay, so we have 1 minus 4x cubed. Let me just get a copy of it. I'm gonna screenshot it. And we just need it from like here. That's fine. Matter of fact, I'm gonna suppress that. All right. One more. There we go. Like, yeah, they do these updates and it just, I don't know, I think I just need to get a new device, to be honest. Okay, so fortunately we have Pascal's triangle already ready to go. So it's 1, 3, 3, 1, okay? So it's basically the same thing, okay? Let's see, first I'm just gonna rewrite this. I think we said, we did this one in red, and then in blue, we got this guy, okay? And we see to the power of 3, and that's gonna be, so the first one was a 1, so this comes from Pascal's triangle. And then the first one counts down. I guess you could ignore it because it's always gonna be, well, let's just write it anyway. 1 to the power of 4, sorry, not 4, 3. And then the blue is negative 4x to the power of 0, okay? Then next, I think we said it was 1, 3, 3, 1. So now it's counting down, that's gonna be 1 squared. Blue is counting up, or 1, I think we can get one more on this line. So it's another 3. That one is now power of 1. Negative 4x, this is now squared. This is the last one, so we finish with the 1. Reds are counting down. Blues, 0, 1, 2, 3, okay? So then if we simplify this, the first term, everything collapses to 1, okay? Let's see, negative 4x times 3. So it's a negative 12x. Okay, the next one is gonna be positive. 4 times 4 is what? 16 times 3 is 30 plus 18 is 48. So 48x squared. Okay, last one's gonna be negative 16 times 4. 40 plus 24 is 64. Okay, 64x. Is that right? 40 plus 24, yeah? 64x cubed, okay? All right, I feel confident in that. Here. All right. So let's see, we got 1 minus 12x plus 48x squared minus 64x. Okay. All right, let's see if we can find our error. Minus 4x cubed, row 3. Did we use row 3? Yeah, 1, 3, 3, 1. 1, so well, that's fine. Yeah, that's a 3, 2, 1, 0, 0, 1, 2, 3, 1, 3, 3, 1. So the first one should be a 1. 4 times 3 is 12, so that's a negative 12x. 4 times 4 is 16, times 3 is 30, plus 18 is 48. 48x squared minus 16 times 4. 40 plus 24 is 64. X cubed. Oh, minus, right? I put a plus. Minus. Yeah, we just had the wrong sign. We got time for maybe 2 more. Expand this using Pascal's triangle. Okay, I'm just going to write it. So we have x plus 3 to the power of 4. Okay, x plus 3 to the power of 4. Okay, let's see. I think it goes 1, 4, 6, 4, 1. All right, I think that's how it goes from Pascal's triangle. So this is going to be equal to, first one that comes down is a 1. The reds are counting down, so it starts at power of 4. The blues, and here, just to be clear, this guy is red. This guy is blue. Okay. So the blues are counting up, and from there it's just a repeat. Should be 5 terms. So then, so the next one is 4, right? X to the power of 3, 3 to the power of 1. And next is 6. X 4, 3, 2. Blues 0, 1. So then 3 squared. Okay, let's keep going. So then I think it starts to count down from that point. So now it's at 4. The reds, 4, 3, 2, 1. And the blues, 0, 1, 2, 3. Okay. And then this guy. 4, 3, 2, 1, 0. And the blue, 4. Okay. All right. Yeah, this is gonna be it. Let's see. So this one collapses to 1. This one is already 1. So then we have x to the power of 4. Let's see. 4 times 3 is 12. So then plus 12x cubed. 9 times 6 is 54. So 54 x squared. 27. 80 plus 28 is 108, and heart breaks. So plus 108 x. 81, right? Is the last one. Okay. All right, like, so once you kind of get the concept, this is more tedious than anything. You know what I mean? It's not too difficult. You just gotta, it's more so tedious. That's the challenge. Just being meticulous and taking your time. Like, to me, the challenge oftentimes with math is just the thing of slowing down, right? Let me go with this. Okay. So then we have x to the power of 4. Plus 12x cubed, x to the power of 3, plus 54x squared, plus 108x, 81. 81, okay. All right. Yeah, that's enough. Okay, guys, did you have any questions for me? Any questions? Let me, so I know we took care of the one from the start of class. So, you know, I went on to give him credit for that. And then let me go ahead and make a copy of what you saw me writing. Let me make it available for you all. That's not right. Notes, this one. Okay, that's fine. Okay, so when this bar finishes loading, you'll get a copy of anything that you saw me writing today. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.